All right, let's go ahead and get started, since we're right at 1:30. So first, welcome to the Exchange Storage for Insiders talk. My name is Nathan Mugley. I work at Microsoft, and I'm the ESC Database Engine Program Manager. And with me today, I have Todd.
Hi, I'm Todd Luutinen. I'm one of the program managers in our storage area. And we're going to talk to you about the improvements we've made in 2013.
So here's the agenda for the talk. I really kind of split it out into three main areas. I'm going to talk about some trends in the storage industry, just a couple of them, and these are kind of to seed the conversation that we should have later on today during the Experts Unplugged talk. Let me start by saying, from a housekeeping standpoint, we want to try and hold questions towards the end, and actually, if you can, bring your questions to the talk that's after this one, related to Q&A, storage, HA, etc. So we're going to talk about storage trends. Hopefully this causes some discussion. It's by no means comprehensive for what's going on in the storage industry. They're just things that are on top of our mind and we see important. And if there's things that are more important to you, let us know, and we could talk about them during the Unplugged session. JET, also known as ESC, and by the way, I'll use those names interchangeably. ESC/JET is the database engine that Exchange uses, but JET's also used across Windows, phone, even Xbox One, which is kind of cool. In fact, Windows Phone 8 shipped with 12 JET databases on it, so it's kind of cool working on a database engine that scales all the way from Exchange down to the phone. So JET's still very much under active development across the company. In addition to JET, I'll be talking about what's new in Exchange 2013 SP1 related to ESC, an update on Exchange 2013 SP1 and Windows Server 2012 R2, especially around the area of storage technologies. I've heard a lot of questions at this conference, both tweets and blog posts saying, well, does Exchange support this technology? What's your stance on this? I hope to answer some of those questions by the end of the talk. And we also have a sneak peek at some of our early thinking on features that are under development for post-Exchange 2013 SP1. So kind of a look forward on what we are working on now that may land somewhere in the future. So let's talk about storage trends. First, drives are getting larger, but not necessarily faster. During the next session for talking about the Unplugged session, I'll actually be giving away 2 6 terabyte helium drives to those who bring the best questions. But you can see, 6 terabytes, wow, that's huge. I remember when drives were like 100 megs or 200 megs. So drives are getting larger, but they're not necessarily getting faster. Why is that a concern? Well, certainly as the price point moves in the industry, there's an advantage to going with larger drives, 4 terabyte, 6 terabyte, hopefully 8 terabyte by the end of the year, especially when you talk about being able to put multiple databases on it, et cetera. But the drives, the time it takes to fill those drives is actually not increasing with the size. So that's one trend. Another trend around larger but not faster drives is areal density is slowing. We talk about 6 terabyte, 8 terabyte, 10 terabyte drives, and these things are huge. But if you actually look beyond that, what you find is the amount of bits that the hard drive manufacturer are able to put on each one of the platters is slowing. We've heard statements all the way up to about the drives maxing out at about 1.2 terabytes per platter. And actually, let me take a step back and say, most drive technology today that isn't solid state or PCIe flash is something called PMR, or perpendicular magnetic recording. That's the drive technology if you have spinning media that you're using. PMR has this upper limit of areal density of about 1.2 terabytes. So let me explain what these graphs are. If you start kind of in the top left, what that graph shows, the top line is what we hear from both drive manufacturers and market research analysts like IDC on where they see drive capacity growing in the coming years. So by 2017, we're told 12, 16 terabyte drives should land. But if you look at the areal density required to reach those drives, even at 7 platters, you'll find that the dotted line below where it says roughly 2.2 terabytes, that exceeds the PMR density capacity. So the question is, how do you get to 12, 14, 16 terabyte drives? You're going to need some other technology on top of PMR to do that. And I'll be talking a little bit about one of those assist technologies called shingled magnetic recording. How many people here have heard of SMR drives? Anybody? 1, 2, 3, all in the exchange group, specifically my team. All right. So this will be new to you. And why SMR is such a concern to us. And shingled magnetic recording drives are basically as I said, an areal density improvement technology that sits on top of PMR. The reason that I'm talking about shingled magnetic recording drives is because when the drive lays down the tracks, it lays them down in a shingled fashion, just like shingles on a roof. Now, why is that interesting? Well, if you're a database developer, such as myself, there's a technical idiosyncrasy with SMR drives, which is they suffer from what's called a copy on write or an update in place. So when you go to update a shingled track that's laid down very close and adjacent to the ones next to it, if you update just 32 kilobytes, the drive has to actually lift up all the downstream shingles and write them out. So what looks like a 32K write can actually turn into several megs. And it's quite a problem for us in the JET team because for 20 years we've been told, you can do updates in place, they're not a problem. And now with the onset of shingled drives in the coming years, it'll be much difficult to be able to use the same techniques we've used in the past to optimize for performance. So shingled drives, certainly for us in Exchange and JET, will cause us to have to rethink how we lay out our data. One other note about shingled drives is they're actually shipping. Toshiba made an announcement last year that they've shipped over 1 million of these units already, and they may or may not necessarily be labeled as shingled. The scenarios that they're shipping, and by the way, shingled drives make great sense if you have like perfect append type I/O. So they look like a DVD in some ways or a CD-ROM. If you start at LBA 0 and you just kind of write sequentially all the way to the end, you get great performance, and the capacity benefits with shingled really kind of help you out because you should be getting 20 to 30% more capacity with SMR drives. So applications like backup or DVR, like security recording, things where you write once and then you kind of just keep writing until you reach the end, and then you may go back and read it, but really you just lay things out sequentially. Those make a lot of sense for SMR. Now, if you're a database engine and you like to do things like updates in place as users get mail or update data in a table somewhere, this is quite problematic because you may be going back and updating a place on the drive that is already been laid down, and then the drive's got to go and basically rewrite all those shingle tracks later on. So the takeaway with SMR drives is, at least for enterprise and data center environments, they are still a ways away. There's specialty applications that drive manufacturers are shipping right now. All database engines, whether it's Microsoft, Linux, or anything else, or SQL or JET, are going to have to change their I/O pattern to take advantage of this shingled drives. But for now, Exchange 2013, both RTM and SP1 are not supported on SMR drives. Ironically, one way that people are determining whether or not a drive is shingled or not is they run jet stress on it, because we have not been able to get a successful jet stress pass on a shingled drive. So our own Windows team, and as well as other operating systems, the drive doesn't always say it's shingled. There's no way to always identify it. So one of the ways that they've been identifying shingled drives is they run jet stress and see. I don't know if I should be proud of that fact or a little bit concerned. but it's like an 80 or 90% perf regression. So someday we'll have to support SMR, but for now, 2013 is not supported with SMR drives. Oh, one more thing about SMR drives. I'm sure most people working with storage have heard about HAMR. HAMR is still something that we've heard is a kind of a ways out. There's a lot of manufacturing difficulties, shall we say. The last update I heard from drive manufacturers on HAMR was that they're still trying to make sure that the platter doesn't melt when they use the laser to do the update. So, you know, I can see that being a complexity that they should probably solve. Oh, if that wasn't enough, we've also heard that all HAMR drives, whenever they land, sometime in the mythical future, will all be shingled as well. So, great. We've got our work cut out for us. All right, next storage trend, data at rest protection. My boss is in the room here, and when I was reviewing the slides before coming down to MEC here, he said, "Are you really sure you want to talk about security and use a photo of a rusty bolt lock?" And I said, "Absolutely." I'll have this great message around it, talking to people about how security is something that you have to keep investing in, otherwise it'll rust. And when I talk about security, I'm not so much saying where things are at in the past or a dire prediction about the future. I'm saying that I believe things can get better with security, and certainly, well, I'll get to that in a second. So talking at data at rest protection, one of the things that we clearly see is that security is moving farther down the stack. Usually people think of security as something like SSL or ACLs or authentication, things that you do at the software layer. But more and more, security is becoming a concept that is a part of the conversation at the storage layer. If you've, some of these newer hard drives have something called they're called self-encrypting drives, where the drives themselves actually have in their firmware the ability to do like AES type encryption. So certainly, moving down the stack is very something that's going on and definitely a trend. As far as data at rest protection goes, the recommendation from the Exchange team is to use BitLocker. And I'm not sure how many people know about this, but the Office 365 service for mailbox data has actually deployed BitLocker. So all the databases for customer email data on Office 365 are on BitLocker volumes. I was the project manager for that. It was kind of an exciting project to drive. And the really cool thing about it is we had our volumes BitLockered, or in the process of being BitLockered, before the NSA Snowden announcement. So certainly that helped prove why we did the project. But we were certainly committed to data at rest protection even before the NSA leaks. And now that those have happened, certainly data at rest protection has become something that all of our customers for Office 365 are asking. So we're kind of proud to say that we provide data at rest protection for our service. Power consumption. Why am I talking about power consumption with storage? Power consumption is not something that people are generally used to thinking about with storage. Yes, hard drives spin, they take up power, but there are some technologies coming out, such as helium drives, and I'm totally smitten with these drives. Helium drives are basically a technology where instead of using oxygen inside of the sealed drive manufacturers are using helium. And what that allows them to do is put more platters, up to 7 in these drives. And because when the drive, they can only put more platters in there because of the fact that helium uses less friction than oxygen, as well as less vibrations. And how does that tie back to power? Helium drives, because of the less friction, the less drag as the platters move through the helium gas, actually use on average 2 less watts compared to non-helium drives. So not only do you get larger capacity drives, but it's also good for the environment, except for if there's a leak. But they've been doing a lot of work to seal them, from what I understand. All kinds of jokes there. Your drive fails, floats away. Actually, though, they are lighter. And one of the selling points, if you look at the drive manufacturers that are building on helium, and there's multiple manufacturers working with helium. They say that they require less HVAC and less cooling energy because they're cooler drives, I suppose. All right, so I want to talk about power on phone. It was a real struggle to get this slide included because people are like, you're here to talk about Exchange 2013 and email. What are you doing talking about a power consumption on the phone? Well, I'm proud to say that on Windows Phone at least, Windows Phone 8 and later, the email application that is on the home screen as well as the calendar and the contacts resides in the JET database. Our research team actually, folks from our Microsoft Research went out and did this analysis where they were looking at power consumption because they look for things like this related specifically to email synchronization. They did this, we didn't commission them to do this, they were doing it because they're research guys and they like kind of geeky stuff as in, how many milliwatts does it take to synchronize email. But I thought this was kind of interesting, especially when we talk about how do we frame the discussion in the future, is to think about power consumption or your service not just as what the servers in the data center, but also thinking about power end to end. The charts here, and there's actually a link to the PDF on research.microsoft.com, and in a test they found, comparing to Gmail as well as Android, Exchange synchronizing email to Windows Phone was by far the most power efficient platform. I thought that was kind of cool. So, yes, power efficient on phone as well. So, as far as closing out the trends piece, what are some takeaways? Let me start by saying, well, why do we care about, or why does Exchange care about larger drives? We absolutely, if you've heard in other talks, and you'll continue to hear in the future, we care about COGS and IOPS reduction. You might have seen some slides that show like 90% IOPS reduction compared to Exchange 2003 or 2007. We are absolutely committed to being able to have Exchange run on the cheapest commodity hardware you can find, whether it's buying hard drives off of eBay or bargain bin drives down at Fry's. We absolutely care about making sure that we run resilient on cheap commodity hardware and we run efficiently. And so we have, as far as email storage, the best platform from a cost perspective. We are not done reducing IOPS. We are absolutely going to keep continuing that trend of reducing IOPS so that you can take advantage of these larger drives through mechanisms like larger mailboxes, putting more mailboxes per database, or having multiple databases per volume. So the recommendation from the Exchange team is still stay with JBOD. I didn't talk about SSDs, and I'll talk about tiering in just a little bit. If SSDs and tiering is something that makes sense for your business, that's certainly things we can talk about. But from our standpoint, the cheapest platform we can run on is definitely still and continues to be JBOD on cheap commodity hardware. And we look forward to, as these drives get larger, being able to take advantage of that larger capacity. So our recommendation, if you'd ask us the best way to configure storage, stay with JBOD, cheap commodity hardware. We call it riding the IOPS capacity curve, which we think will probably up till about 10 terabyte drives will still make the most cost sense. After 10 terabyte, we're looking at SMR and things the crystal ball gets a little murky, shall we say, on what happens after that. SMR drives are not supported with Exchange Server 2013. Not a huge deal because the high capacity, high IOPS SMR drives are not shipping yet from manufacturers. Data at rest protection. BitLocker is a great solution if you need to encrypt your storage. As with all encryption technologies, the complexity and the interesting parts are always in the key management. So that's something that you'll want to take into account, is how do you manage your keys. But one thing about BitLocker I just want to close on is in Office 365, we obviously have servers, and servers have drives that fail. The industry failure rate is about 10% for AFR. One of the reason when we deployed BitLocker, that one of the scenarios we were really interested in closing in terms of a security gap was when a drive fails. It doesn't always fail binary where it's working or it's not. They kind of limp along for a while and just kind of take their sweet time getting back to your reads and writes, and in which case usually you might go and replace it. With BitLocker, for the service, for Office 365, we wanted to make sure that when that drive gets replaced, that regardless of the state of the drive, that we can say with certainty that the drive is encrypted. So when it comes to data at rest protection, don't ignore the failed drive type scenarios, which is a relatively easy one to solve. I don't see much of a future in the enterprise for self-encrypting drives. There's a lot of questions on, does it solve the stealing the whole server? How do you do key management? Can I use external asymmetric keys like certs, or am I stuck with whatever they're managing? I think it's a cool concept, but they also have some restrictions on being able, the drives have to be plugged directly into the ATA channel, and if you use things like battery-backed write cache array controllers, you can't use self-encrypting drives. So if they work for you, great. At least it's a data at rest protection. And lastly, on power consumption, don't ignore the benefit of power efficiency. I don't just say that to be eco or green. I say that also because there is big cost savings to be had with technologies that increase power. All right, with that, we'll move off of storage trends and let's talk about what's new for Jet in SP1. So the way that I would frame improvements to Exchange 2013 SP1 is that they were incremental in nature. If you have experience with 2013, you've done testing with JetStress or the mailbox calculator, you've got some idea how many servers and what it's going to look like. It was definitely a goal of SP1 to make it so that you didn't have to go back and retest on your hardware. So the improvements with SP1 are more incremental in nature, additive. So with that, let me go into some specifics. One of the things that we did for Jet specifically, and Todd will talk about store-specific improvements for SP1, is for Jet we added a bunch of tracing. I'm sure everybody knows that Jet, with Squeaky Lobster, has got hundreds of perf counters. We have more perf counters than any other component in Windows. I don't know if I'm proud or ashamed of that fact, but certainly we don't want to just keep piling on perf counters. There's this great infrastructure in Windows called ETW. If you've ever used Xmon or used any of the data collection mechanisms in perfmon, you might have some familiarity with ETW. So for us, we went through an SP1, and there won't be a test on this. You don't have to memorize everything on the far right side. It was more just to kind of showcase all the various components of ESE that we instrumented with ETW traces for SP1. ETW is probably not something that these traces aren't exactly something you probably interact with on a day-to-day basis. It could be something that product support works with you to enable to find out what's going on in the system, or if you're really kind of geeky and nerdy and you just really want to know what Jet's doing, now you can tell. We certainly like to know what Jet's doing, but so we've traced everything from APIs to I/O. I'll be writing some blog posts about how you can use this tracing to solve specific scenarios, like being able to tell if your I/O is coming back really slow and where is that I/O originating from. This tracing and performance infrastructure, we're going to keep investing and evolving in that. So expect in the coming years, at future mechs, we'll keep talking about ETW. How many people here have used XPerf? Anybody? Oh yes, more than SMR. Okay. If you know XPerf, you know ETW. Wonderful. And there's actually, I include some comments on how you can actually turn this on and how to use XPerf. For those who didn't raise their hands, XPerf is a utility that kind of really allows you to look at a system through a microscope or a straw. It's part of the Windows Performance Analysis Kit. Toolkit, thank you. Windows Performance Analysis Toolkit. Yes. Just if you go on Microsoft.com and you type in XPerf or WPA, you can download the tool and play around with it. I like it. JetStress, I'm sure everybody in here is familiar with JetStress. After 2013 shipped, based on our previous commitments of releasing an update to JetStress, we did. And I'll talk a little bit in a couple slides about what those improvements to JetStress are. There's just a couple ones. Performance, we did a host of performance improvements. Probably one of the bigger one is around increasing perf of database extension by 30%. Pretty exciting to us because we always look for IOPS win. Another tool that I'm sure everybody's familiar with is EasyUtil. We took a bunch of the options and commands that were only available in the debug builds and made them available in retail. So if you've ever used EasyUtil to dump out a space report or to dump logs because you really cared about that or you've required, now there's a whole lot more information with EasyUtil. I think that's all for that. Last but not least, under the optics tracing for what's new for SP1, we added our first event channel, also known as a Crimson debug channel. On your Exchange servers, if you open up Event Viewer and you say Enable Debug Logs, you navigate down to, what is that? Microsoft Exchange ESC. You'll see this channel called I/O Diagnose. If you enable that, it actually turns on the I/O ETW tracing, and you can start to get data for when your I/O is complete. I wouldn't recommend running this all the time, but if you were just kind of curious to say, hey, how are my I/Os doing this morning? Well, now you can get, figure that out. Some of the fields that we have are like the size of the I/O. The interesting piece are things, the CMSEC time and queue is basically how long it took for the I/O to come back. So one scenario could be troubleshooting hung I/O, and you can see here what Jet thinks how long it took the I/O to complete. And I'll probably clean up some of these field names because IORP and IORS are not very friendly names. Yeah. All right, Jet Stress. We shipped it March last year for the 2013 version, and we've actually made some several bug fixes to it based on what you've told us, issues you've hit. We actually have another, the last update was around September 11th, and that was a fix that we did for a bug around having too many databases on a server. We have another update coming for how we do logical discounters, and that should be posted at Microsoft.com when I'm not up here talking, so come in the coming weeks when I get back to Microsoft. As far as improvements we've made to 2013, one option that we heard, and I'm not saying any of these are like rocket science or monumental, just to kind of give, here's what's new for the tool. We have the ability to continue jet stress if a bad drive is encountered. This is kind of a minor improvement, but a lot of customers said, hey, I've got 30, 40 drives in my system, and I use it to burn in my hardware, and if one of those drives fails, I don't want to have to restart a test that was taking 3 days. So we now have a checkbox. That's your problem. This checkbox is for you. One that's more substantial, I don't expect you to read this text. I'll kind of tell you what it means. Basically, if jet stress encounters a lost flush, so this is basically it's almost always bad hardware. Actually, it is almost always bad hardware. Jet doesn't have bugs. We just have bad hardware. So if you have bad hardware, or it could be a bad driver, or a Windows bug, never a Jet bug, we basically will fail the test. We should have always failed the test. If you get a lost flush on your storage hardware, that is like, ship it back to the company. Lost flush is very catastrophic. We should have always failed jet stress on a lost flush being detected. Now we actually do. So if a lost flush is encountered during the jet stress run, it will fail. And we should make it like blinking, but it's not. The text below, I know it's too small to see, but basically it tells you what drive the lost flush was encountered on and some specifics about what was encountered. All right, with that, let's talk about an update on 2012 R2. And this slide is one that I know a lot of people are interested in. What does Exchange 2013 SP1 support when it comes to storage technologies for Windows Server 2012 R2? For storage spaces, this is the Windows feature where storage spaces is kind of a whole galaxy of features. We've tested Exchange 2013 SP1 with storage spaces, so it's supported. I wouldn't say it's something we recommend as a best practice because JBOD and RAID 0 type drive configurations are plenty good enough, but we have tested it. Storage tiering is another technology that we support with Exchange 2013 SP1. It's been tested. I wouldn't say it's a best practice unless that's something that's very important to your business, but we do support it. REFS. I've heard comments both ways saying, Exchange, do you guys support REFS? Do you not support REFS? REFS is a new file system that was introduced in 2012. You can only use it for data volumes as a non-OS drives. REFS is supported with Exchange 2013 SP1. There is a best practice that's highly recommended, which is, in fact, I would say, just do this. REFS provides a feature called integrity checking, where basically if you get a lost write, it will tell the application you've got a lost write. Jet also does that as well. And unless you like to make sure that you've got two systems doing lost flux detection because you want to be really, really sure, the best practice is to turn off and disable REFS integrity checking, which you can do with a commandlet called set file integrity or something like that. And you can set it at a folder level and have it inherit to all the child files, such as the database and the log file. But if you want to run on REFS, which actually I kind of recommend, I like REFS, make sure that you've got integrity disabled. The chart on the right shows testing that we did with JetStress on REFS volumes, both with and without integrity checking. And I think that's probably a 20% perf decrease if you leave it enabled. So unless you have that many IOPS to spare, and again, you just really want to make sure that you don't lose data, then turn it off. Surprisingly, REFS for a new file system, because they don't exactly show up every release of Windows, outperformed NTFS by a very, very small margin. But again, REFS is supported with Exchange 2013. Data deduplication is a feature we do not support for live copies of the database. I don't know if there's a lot of great scenarios around it either when it comes to Exchange, but just to be clear, data dedupe is not supported. All right, looking ahead, what's coming down the pipeline? And let me just start by saying these features, we're not committing to a release. They may not make it. We'll ship them when they're ready. But some of the stuff that we are actively working on is one of the scenarios is database resiliency, both in the HA scenario and again just on single server, single drive resiliency. We're doing a feature around looking via HA the ability to detect database divergence between various copies. We will continue, another scenario is performance and IOPS reduction, and I might as well get this tattooed on the slide deck. We will always keep improving IOPS and performance. We have a bunch of different features we are investing in that gives us 5 and 6% type IOPS reduction, but when you do 5 or 10 of those, they definitely add up. Optics, we're going to keep investing in our tracing work so we know what's going on with Jet. Optics is kind of one of those investment areas we do for ourselves because we want to know more what Jet is doing. It allows us to help figure out things like, when we do an IOPS reduction piece, what's the benefit or where is our IO going? But I think under certain scenarios, it also helps customers well, especially for troubleshooting. And we're also going to take some of that optics tracing investment and expose it up to some of the Exchange tools like XMON. So now you'll get even more precise data than you did before. I know how many people here are a developer? Would classify themselves as a developer? All right. Well, non-Exchange team related. You don't work for Microsoft, right? So when I read the attendee report, they're like, okay, 5% of people that come to MEC are developers. For Jet, so let me jump ahead for a second. We are a database engine. We like people using us, Exchange, Windows, even third party. We've got a couple areas that we are investing in around the managed experience for Jet, and since this really only applies to one person in the room, that's as much as I'm going to say on it. But it's a great experience, let me tell you. And let me jump back. Under performance and IOPS, again, looking what's coming down the pipeline, we are looking at a feature, or working on a feature, that allows search to index from passive copies. And basically, the goal is today in HA, if you've got 3 or 4 database copies for search to index content, they all go back to the active, even on the passive copies. By having search be able to index from the local passive copy, this significantly reduces WAN bandwidth and IOPS as well. So that should be pretty exciting. Log compression, basically the ability to reduce WAN usage. I kind of think about that as IOPS reduction, even though it's for WAN, but WAN usage is certainly an area that we're going to keep investing in as well. Store, my customer, sits above me on the stack, stores attachments as in a type of JET table called a long value, and we're looking at some ways to make sure that stays contiguous and defragmented, especially for databases that have been mounted and attached for like months on end. Certainly it makes my life a lot easier if you could take the database offline and do an offline defrag, but Store won't allow me to do that anymore, so we have to defrag while it's live, which is always kind of exciting. Under the optics piece, this is a screenshot from a recent Exchange build with some of the new tracing added. This may or may not be exciting to you. We tend to think it's exciting, but this is XPerf with the improved JET tracing that's we're working on for post SP1, and you can actually see some new data, or maybe you can't see, but if you look at the slide deck after, it's great. There's some additional fields that tell you why the I/O happened and who the client was and how big it was and where it went to the drive. So if you're kind of a control freak in terms of wanting to know where your I/O goes, this is the feature for you. I think that's all there is on that. Dev experience. I also author the MSDN blog for JET. I created it 2 days ago, so content is still forthcoming. But at least we have a blog now. The JET team is very much active. I get questions a lot, like, hey, the number one question I get about JET is JET still alive? Absolutely. Now we have a blog to prove it. On that blog, we will be talking about the features of persistent dictionary and ISAM layer features aimed at very sophisticated IT pros, because you can do some of this through PowerShell, but more the developers that need a structured storage engine. And my boss won't let me talk about this slide anymore. So with that, I'm going to pass it off to Todd, who's going to talk about Store.
Thanks, Nate. Well, now that you've got a good foundation for, I guess, the investment areas of where we're looking at in trends in storage and how we start to use that, the application layer, on up above the ESE layer, we have the information store. And I'm going to give a brief history lesson of where we've been, where we've gotten to, an overview of the architecture in 2013, and then talk about some of the new features that we've enabled since we released last year. As a basis, what is Store? When we talk about Store, it's actually changed over time, so I want to give you the current view of what Store is. And in the history, I'll show you how that's changed as well. It's generally responsible for the operations against a mailbox database. So those come through RPC operations from some other tier in the Exchange product. There'll be processes such as the client access service, the OA process, or the ActiveSync process that are receiving requests from clients and translating those into RPC operations that are sent to the Store process. And that's how items are being read or written into the mailbox database. It also controls access control to the items in the mailbox, either at the mailbox layer or at a folder layer. It's providing management of the indices associated with views over those items. And this is probably the biggest thing that it does, in that when you look at your mailbox, you think of these list views of tremendous numbers of items in, say, your inbox. You sort the items by most recent or least recent items, and it's indices that allow for those fast views to be produced by the clients that are, again, producing these RPC operations against the storage. The last two are kind of internals, reliable events that support event-based assistance, which is a way for us to enhance the business logic that is associated with the data in our mailbox databases, and then maintenance tasks that maintain those mailbox databases. And an example of that is the process that goes through and disconnects and drops mailboxes when the AD objects have been removed. It's kind of a brief, but looking back, what was STOR? We've been here for a long time. This is kind of a retrospective experience at MEC this year. I wanted to give a little history there. But anybody remember the Alpha processor? The Exchange 4.0 running on Alpha processors. I remember a lot of customers deployed those digital servers. We had a bundled directory service before Active Directory, a single process that supported all of the MAPI clients and supported 2 databases, one public, one private database. And storage, wow, at the end of that, was really getting up to about 200 gigabytes on these big RAID 5 arrays. Seems really small by today's standards, especially 10 megabyte mailboxes with PST storage on the clients. Didn't even store the mail on the server because we didn't have things like OA and Exchange 4.0. It was get that message off the server as fast as possible into a client store. It's hard to believe that we operated that way. We came out with 2000. We started adding more features. Now just on the 386 architecture, but now supporting address space up to 3 gigabytes, bigger cache. Think bigger cache in that 3 gigabytes of user address space. We're now dependent on Windows Active Directory. We're still a single native STOR process, though, and we're still supporting MAPI clients. So there's a lot of logic in STOR still dealing with client connectivity and the rendering of things that clients understand. Native processes that start to front-end that with POP IMAP OA and SMTP, and support for 20 databases per server. Mailboxes are about 100 megabytes in most customers. We start to have client OSTs and PST storage for archives still. Still a difficult management story in the enterprise space. In 2007 and 2012, we moved to the x64 architecture, and here's where we start to take advantage of much larger memory systems inside of the servers we're deployed on. We start to move towards managed code implementations in our protocol layers, and we separate those protocol layers from the storage using some internal technology that we call XSO, Exchange Storage Objects. This allows us to move some of the business logic around the storage out into our middle tier and start to innovate with new business logic that's outside of the core storage. An integration of full text, kind of a second generation, and we start to see mailbox sizes get up over a gigabyte, some deploying as large as 10 gigabytes, and we have OST storage for primary. We have the introduction of archives. 2013, where are we now? Again, we now support that x64 architecture. We've now re-implemented the STOR process into a managed code implementation with multiple processes, one worker process per database. We've still got these managed protocol processes, but now we've got a clear delineation between a middle tier that's supporting the business logic associated with specific protocols and storage. It's just core storage with the data associated with it. It's a very clear delineation. Some of the things we carried in our previous STOR implementation in native code has now been freed. It's the legacy that's no longer carried with us since the initial release, and we've started afresh with this managed implementation. Inter-process communications are now over this XSO, but now using local RPC, as you've heard about. We're trying to consolidate the business logic of a server to the server supporting the mailbox and the user accessing that mailbox all on one server. We don't want cross-process communication between servers using non-standard protocols. When it's cross-server, it's HTTP. When it's on the server, it's RPC, and it's primarily local RPC. It's not bundling on top of TCP anymore. We just have support for 100 databases, as we did in 2010 with a release of CU2. And we've got a third-generation integrated full-text search. Our database replication technologies have continued to evolve, and as Greg and Abram and Dimitri have talked about in the last session and our Q&A session coming up, tremendous advances in replication for resiliency. And we're now able to support things like 200 gigabyte mailboxes, 200 gigabyte archives to provide virtually unlimited storage to customers. With the advent of Outlook 2013 with OST Sync Slider, it allows for a subset of that data to be taken offline, and that was shown in one of the sessions earlier this week about how my device with limited solid-state storage doesn't need to contain the entire history of my mail. It only has the most relevant recent data. And then with the integration in hybrid mode, allows me to access this wealth of data that now exists in the cloud or in your services that you operate on premises. What this new architecture looks like is you take the top of the picture, we have a set of client processes, and this kind of calls out each process that gains access to the mailbox on behalf of some client protocol like POP, IMAP, or OA. Those processes have built into them layers of code that allow for them to access mailbox storage on behalf of the mailbox the person's logged in as. And when they do so, they access a store worker process that's associated with each physical mailbox database that's stored on the disk. The logical structure of that code's kind of revealed here into a nice layering in our managed code implementation so that we can manage things like the parsing of RPC protocol in a very distinct layer that's distinctly separate from the concepts of logical mailbox structure with folders and items, and then a physical layer as you go down the stack of how we represent that on top of an actual database implementation such as JET. Then underneath, we actually have the JET implementation with a managed layer and then the JET core functions underneath that. On the side, we have kind of an infrastructure for providing store common services that allow for us to run maintenance tasks, things in the background on behalf of client operations or as part of cleanup activities that occur for normal maintenance over the life cycle of a mailbox. Then we have a couple of extra processes that Store is integrated with quite heavily. As we were in the previous release, we made some more conscious decisions about what that integration was. We have the replication service where the active manager exists. This is what controls the activation, mount and dismount operations of databases in Store. And that's all communicated through the Store process, which controls the process lifetime associated with a database. When a database goes into passive mode, it's Active Manager that tells the Store service to activate a passive worker process. And at that point, some things happen in that process. So it's all that integration on the left side, which are processes that are doing the lifetime management. Around the database schema itself, I've talked about this previously. I want to go over it quickly again, though. The tools we use to reduce I/O that Nate talks about are really in three core areas. Those general approaches haven't changed over time. It's how do we take specific scenarios and use these mechanisms to reduce I/O. Physical contiguity, Nate talked specifically about long value trees. How do we keep things close together so we can write sequentially in large blocks and read sequentially from contiguous pages on the disk so they're not randomly seeking to those locations on disk. And that excellent physical contiguity allows for us to read and write in a more sequential manner, increasing the performance of the drive. It has a certain performance characteristic when it's randomly reading and writing, and a different performance criteria when it's sequentially reading and writing. We'd like for it to operate on the sequential side of its performance characteristics. Logical contiguity is the concept of laying the data in the database out in a way that items in a mailbox are co-located. So messages in a message table for the same mailbox are close together so that the pages with those messages are close together in physical contiguity, and we can issue reads against that data and produce sequential reads for a series of items to produce views or to construct indices for those views. And that gets into temporal contiguity. How often do we update indices in order to produce these views that clients that rely on in order to produce these snappy experiences, changing folders or changing sort views or looking at conversations versus item views? These index operations, if you look historically, were done every time we do a CRUD operation on the mailbox database. You add an item or remove an item, we'd update an index. Now we don't do that. We accumulate those over time, and just in time of the client actually requesting the index, we go and update that index at the time the operation is performed by the client. This allows us to coalesce those updates and, again, get into more sequential read and write operations. These are generally the tools we use, and we will continue to do this. We've identified a number of areas where core scenarios we can optimize by making these more the contiguous nature of these operations occur with more proactive reading data into sequential reads or sequential writes. So still have some doing here. Some schema elements. I mentioned that there are some tables that are partitioned by mailbox number. It's kind of an internal implementation of the storage schema that says when we build a table of data, we'll partition it by a mailbox number, and that's associated with the mailbox that you know of associated with the Active Directory object. The mailbox tables that are partitioned in this way include the folders and messages, attachments, and physical indices that I keep referring to for views. Some global tables that also exist that generally don't think about regularly are things like a mailbox table. There is a table that defines all of the mailboxes that exist in a particular database and have some of the core characteristics of those mailboxes. Things like aggregates on the number of items that exist in that mailbox that are updated as the CRUD operations occur in that mailbox. The delivered to tables, one that's existed for quite some time, that allows us to do duplicate message delivery detection so that when a message of the same message ID and date sent is received by a mailbox, we can quickly determine whether it's a duplicate or not and tell transport, no, we don't need to deliver this again. Events are a way for us to record the CRUD operations in a reliable way and communicate those to an assistance infrastructure, again, where I mentioned there's additional business logic that allows for us to write new capabilities around the storage itself. It doesn't have to be built in the storage layer. It kind of sits on the outside of it. So one of the things that we did in our schema is we changed the way that the messages are stored in the database in 2013. One of the core ways we did this was to move everything into a blob structure when we stored it in the JET database. This blob structure allows us to, again, write a big blob into the database, into a series of pages for long values when it's large information, or to maintain it on a single page when it's small or much sparser information. Think metadata. This is what we refer to as our property blob, which is the metadata associated with a message that's typically used to build views. Sometimes views are created on the off-page property blob, but this is generally where things like the body of the message are contained. Think large blobs associated with a message that aren't attachments. And this allows us to store it and push it into an LV tree. We give hints into JET to say, we want to keep this on page or we want to push it off page, and that allows us to control the behavior of how things are stored in the JET database. Database cache management becomes important because as we're producing I/O on the disk subsystem, we need to be able to cache efficiently those pages that are frequently used. So we talked about the globals table. If we can keep information in the globals table in memory, in the cache, then when we're doing things like delivery to a mailbox, we won't have to read some of the pages that we'd have to read otherwise if they got pushed out of cache. It's not necessarily the items that we're putting in cache, but there's structural things about the database that have to exist to reduce the I/O. So we want to make sure there's enough memory allocated. In 2013, though, we have far less memory budget than we had in previous releases. When you ran dedicated mailbox servers, you'd pretty much give all the memory to JET cache. It's not the world we live in today's implementation where we have client processes and the search processes all running on a single box, and we need to allocate much less memory to JET cache. It's using 20% as a max allocation for its algorithms. And from that, divides it between each of the passive and active databases on the server and determines targets for each of those processes based on the number of copies and maximum active databases the server can host. So think of that's all configuration that's somewhat stable. As it changes, it will change that algorithm, but that generally is kind of a point in time of your deployment of when you add databases to a server in terms of its configuration, and then it starts to use those to set its cache targets. Passive databases use far less cache because they're not serving clients, at least not yet. We'll start to see that behavior change a little bit as we start to do indexing from passive, but generally those items that are being indexed are in cache because they've entered the database through the replication stream. So we don't anticipate this will change significantly for passive databases. And then when we activate databases, we make a quick transition from passive to active, we increase the memory budget that can be used for the cache in that active process such that it can start to cache more data. And what we see in IOPS trends is we see a reduction of I/O over this time frame. Again, I didn't go all the way back to 4.0. I think we have measurements of how bad it was there. It'd probably be 99.999%. But again, I speak to a different number than Ross presents. 99%, I put a little caveat down below. It's like with an equal usage profile. You can see a 99% reduction in I/O between these two platforms. But in reality, it's a 93% reduction with the usage profile changes we've seen over time. An example of that is the proliferation of mobile devices. A much larger percentage of users using mobile devices and the I/O characteristics associated with those are rolled into that 93% number. It says, we use the store more, but we still reduced its I/O by 93% over the previous generation where we didn't see those devices previously. We've referred to the benefits of using multiple database copies per volume, or JBOD disk. And what we talk about here, I give a simplistic example here across 4 servers with a single disk in each of those servers hosting 4 database copies. And we have active database distribution across those 4 copies. As you notice, it's symmetrically laid out. There's the 4 same database exist on each of the 4 disks on 4 different servers. And by controlling the database copy preference, you can tend to have the active users distributed across those 4 server disks. And the passive I/O, which is less than what the active I/O, is equally distributed across the other servers. And what you get is this nice balance of using all the I/O now in the system. We used to way underuse the passive disk on server copies because we weren't using what was capable while it was passive. As we distribute the actives, we can now fail over an active to another server, and we're now just increasing the active a percentage of overall users that are being hosted on that disk. Rarely, if ever, running all the actives on a single copy. By design, you shouldn't be doing that, and again, this is where budgeting for server and disk failures is based on the number of servers you have and the copies that are supported in that DAG environment to ensure you've budgeted sufficient I/O capacity for the system. And passive I/O is included in that budgeting. If lag copies are used, this is a copy that will not become active, and again, in your budgeting, allows for you to kind of discount the cost of those users on that database for that particular volume. I mentioned earlier about how the processes of the replication process with the Active Manager work together with the store service and the store worker. Again, the replication process is what's responsible for issuing mount and dismount operations, but it's also receiving a channel of information of what we call failure items from each of the processes that are involved with storage. So we have the ESE layer underneath store that can detect bad disks, and it can emit failure items indicating that there are bad disks. Similarly, store can have process runtime issues in which it can communicate to the Active Manager so that it will initiate failovers. Likewise, if search copies are unhealthy, these are additional activities or detections that can drive a failover operation to restore service and the health of the overall system. And then lastly is some of the sessions here are talking about the managed availability and active monitoring that occur in Exchange 2013 and how responders can also initiate failovers of databases or servers. These all happen through these failover channels. Now, store service process is what's receiving the commands for mount and dismount and controlling the process runtime for the database process, these store workers. It's monitoring those processes over a simple channel. So Windows provides capabilities for us to have a handle on the process. If the process exits, it can log a failure item and initiate failover immediately. We don't have to infer the failover has occurred by polling. It happens immediately on actual detection of the process exit. This is quite an improvement over previous release in detecting in that initial few seconds of detecting it immediately. One other thing that it does is when HA wants to move a database between servers, it can issue a dirty dismount. And when issuing a dirty dismount in previous releases, we had to actually stop the database and recover resources. In 2013, recovery of resources is killing a process. We let the operating system have that complexity, and it's allowed us to remove a significant amount of complexity into our application architecture. It was amazing how such a simple concept of just, we can now terminate on a per process basis because that's the scope of the process, is the database that we're failing over. The store worker process controls this transition from passive to active. When it's passive, people tend not to think of passives of doing things, but we've got the block mode replication of a passive database operating in that process. The fast transition into mounted is where this jet cache increases by 5x. We go from a 20% of max to 100% of max allocation. And that's when it starts processing the RPC operations associated with the client protocols. One of the things we did in 2013 as well is the elimination of kind of scheduled maintenance. So on the database object, you used to have a schedule of when would store come along and do all these really resource-intensive operations on the database. Some of those have been pushed into what we call time-based assistance infrastructure, and this provides us the ability to, through an idea called workload management that monitors CPU and replication health, to essentially schedule or initiate work that's discretionary. And we typically do that in non-peak hours because of the resource monitors that detect the health of the system. The health of the system essentially tells us that we can operate. If the health of the system gets unhealthy, it stops doing it. So if it's driving the behavior of becoming unhealthy, it backs off. And it's got certain constraints since release on what times of day it can run. But generally speaking, will run when resources are available. And this allows for us in the service, where we're running 24/7 across all the time zones of the world, of being able to run maintenance on a timely basis without having to schedule specific time and figure out when are people going to be active on a particular database. Some of the things that we do in these processes are what we've done in the past, which is we've got to do some index maintenance. So I talked about just in time bringing indexes up to date. Sometimes indexes are so far behind that we want to opportunistically bring them up to date so that the user experience is improved when they're accessing a folder that's, say, infrequently used. So its maintenance hasn't been performed. We want to opportunistically perform maintenance on those views so that when the user does use them, that they're up to date. We'll start to do things like ISIN tag on the system. We do it in a discretionary workload when you initiate something like new mailbox repair request. We'll start to do some things I'll talk about in the future about when we'll try to schedule that opportunistically, proactively, detect and repair before. Some other discretionary things are like, when do we actually remove the items and indicate to the jet layer that we've deleted objects, attachments associated with messages, and we start to recover the store. Logically, it's removed from the mailbox's allocation of quota at the time somebody performs, I keep referring to CRUD operations, change, updates, deletes. When those operations are performed, we're logically making a view of that mailbox that doesn't include those items, but will actually defer the removal of those items to be somewhat opportunistic, discretionary work, and then move it into more urgent as the discretionary work doesn't have the ability to run. So I talk about urgent maintenances, sub-object cleanup. At some point, we have to start doing cleanup, otherwise we start leaking large amounts of space. And this is if the system's running too hot for too long, you have to do it in an urgent manner. So this is a point at which we boost its priority. Store directory service maintenance is the process of, again, going out and looking for disconnected mailboxes, having a better algorithm for only looking for the things that are likely to be disconnected and not overdo that on every day. It used to be every day we'd go check every object in the mailbox table or the object associated with every item in the mailbox table. Now we kind of look at that. We look at when was the last time we did it? When was the last time they locked on? And with those heuristics, and we can reduce that directory overload. I talked about the resource monitors for CPU and replication health. We'll eventually add something that provides us a better indication of disk latency or disk resource usage. Our initial implementation of the RPC latency monitor was too abstract and it stopped work far too frequently when in fact it wasn't a resource issue. It was an RPC latency issue. Those are two different things, sometimes related. And I'll leave it at that. We can certainly talk about that more in the Q&A if you had questions. Background database scanning is set at a rate which prolongs the activity because the failure rates of the disks in our data center were detected to be more resilient than we had anticipated in 2010 and allowed us to extend that and run it at a lower rate. The periodic tasks to generate quotas just don't happen anymore. It's now done more in line with user activity to reduce the amount of overhead when you have large numbers of mailboxes. Which leads me into quota management. There's been quite a bit of talk about that, and I wanted to provide some more clarity around this. First off is when do we generate over quota notifications? We've transitioned from generating one for every mailbox on a scheduled basis daily to now we record the usage of the mailbox when the operations performing updates to the mailboxes occur, but it's at logon type on a periodic basis that will generate the quota message into the mailbox. So what the result of that is we'll only generate quota notifications on mailboxes that are active. If you logged into your mailbox, you get a quota notification, you go on vacation for 3 weeks, you're not going to get 3 weeks of quota notification. You're going to have the one that was given to you before you left. When you log in, you'll get another one. So you'll get the one that's current at the time you log in. So it's a good example of how now you'll expect the behavior change to occur there instead of being stacked up with kind of this historical of how your mailbox just kept growing. And that reduces a lot of work that we have to do for quota notification. Great efficiency. One of the big things that changed, though, is how we calculate the logical size of the mailbox that's used for quota notifications. In previous releases, we've only counted a subset of the properties that are stored on items within a mailbox. And what that allowed for us, what we found in our service as we started to operate it, was that there were always outlier cases of those properties that we didn't count, sometimes were really large, and would cause mailboxes to consume far more storage than what we wanted. And what we've done by doing this is be able to prevent those cases. A mailbox can't consume more than it actually logically takes on disk. Or logically, I'll say, I'm not going to say on disk. And then, because the logical size is computed differently, the quota you allocate to mailboxes on a migration may need to be changed. We recommend that you actually increase that. It'll be entirely dependent on the content you have in your mailboxes. We've seen some cases where there's no increase. I generally use a number of 30 to 40% because it covered 95 percentile of the mailboxes we've seen. It doesn't mean everything grows 40%. It means all of 95% of mailboxes fit within 40%. Most of them grow very small amounts. So that's where I'd say take a look at your environments to see how they do during your initial migrations. As we did our enhancements in SP1, we focused a lot on management. You can imagine that we're operating a large service like Office 365. Management becomes great overhead. We need to automate things and provide insight into the way the service is operating. And I'll cover the first 4 areas. Scalability is some other areas we need to do in a big service. We heard feedback. We wanted more databases per server. That's where we did 100, went from 50 to 100 databases per server. We made some enhancements to monitoring and some miscellaneous around move. So you move mailboxes. A lot of people use last logon timestamp to determine when was the last mailbox used. Well, that moves with the mailbox now. It's a big need that we had in our service as well. Database schema upgrades, though, is one of the areas that we spent quite a bit of investment because this is an area that allows us to continue to innovate. The idea here is that we wanted to provide an infrastructure to safely upgrade database schema. Now, if you remember 2010 SP1, you had to go take offline significant parts of your DAG deployment when upgrading to SP1 because the databases would upgrade their schema when you upgraded the first server. And you'd better get another server in place with another copy so that I can then actually fail back. And all the servers that hadn't been upgraded, well, that's kind of capacity I can't use until we get those upgraded. What we've done now is we've got a great coordination system now so that we don't upgrade the databases until all the database copies are capable. And I've got an example of that in a second. But we essentially record current database schema info. You can retrieve that with Mailbox Database or Mailbox Database copy status. It allows you to determine the version that the server is capable and what the version the database copy is actually running at. And if you want to manually update a database schema, although I don't think it'll be necessary in most cases, it's possible through the command update database schema. The concept here is that in that same configuration, 4 servers with a disk in each, 4 databases actively distributed across the 4 servers, we can move the databases off the first server and upgrade it. And when we do the upgrade, the server becomes capable of running the new schema version. It attempts to upgrade all the databases at the time it completes the upgrade, but because other servers aren't at the right version, it's not allowed to request that upgrade or succeed in requesting that update. We go to the second server, move off its actives. We upgrade that server. It becomes capable. It gets kind of repetitive, so I'll click through the next 2. And I've got another server that's upgraded. And I move databases around, and I do another one. And at the end of upgrade on the 4th server, when it requests the update of the schema version on the 4 copies that are local on that server, it succeeds because the cluster now knows that all servers have upgraded to a 126 capable version. And so it's now set the requested version on each of the databases that have copies on that server. That doesn't mean that their schema is upgraded yet. Database fails back to server 4, that's when it upgrades its schema. It's on mount. After mount, when users log into their mailboxes, we distribute the schema upgrade associated with mailboxes that on a per mailbox basis will start to upgrade the schema inside of a mailbox. Generally not real significant resource utilization to upgrade schemas. We generally don't do in-place schema upgrades where we're trying to change the format of data. We're generally trying to control version behavior of how the software operates to have before version and after version behavior, or to add new data to databases so that you can support new versions and old messages won't support those capabilities until they're moved to a database with that schema. So you think about it as mailboxes move, you'll get the whole mailbox up to that schema, or new items as they're added will have that schema. Mailbox shape limits are an area in the service where we wanted to control the experience for all the users, preserve the quality of service to prevent runaway conditions. There's always outliers. You're running systems of millions and millions. It always happens. It just happens once in a million. The joke is it happens on Thursday. Limits in Exchange Online I've got published here. They're on the online documentation. We have the capability to support these limits on-premise, but we chose not to enable them. We don't know what you're running on-premise, and we don't want to assert operational behaviors on your on-premise environment, but you're certainly capable of using the commandlets I reference here to be able to set these limits to prevent runaway usage. The limits are on, that's weird, it didn't line up here. Number of messages per folder, number of messages per dumpster folder, because some are used for lots of client views. One is used on a limited client view. Number of folders in a child hierarchy at any level of the hierarchy, and then number of folders or depth of the folder hierarchy. So, of course, getting hundreds of folders deep, can't imagine navigating that. Mailbox statistics was another thing that we wanted to enhance around space management. I talked about how logically an item can take up more space than it was previously accounted for, and we started to see this behavior in 2010. What we got in 2013 was the ability to see actually how much table space we're using in the lower jet layer. And we didn't have to take databases offline and run a mailbox space report or a space report with an offline copy. We can actually get mailbox statistics, and we can start to see the table sizes. So historically, we could see the logical item sizes, and now we can see the table sizes. And as you can see here in this example, I've got roughly a 50 gigabyte mailbox that's actually consuming about 26 gigabytes of space, of table space. Now, the ratio between logical and physical is based on the content. If you notice, this mailbox, it happens to be my mailbox, is very heavy on message content and not attachment content. Mailboxes that are more heavy in attachment content that can't be compressed will tend to have lower ratio of physical to logical. So things with lots of Word documents or uncompressible JPEG images would be a great example of where you'll see that logical ratio go closer to 1:0 instead of the case of mine that's almost 2:0. Mailbox repair tasks allow us to fix mailboxes. We've enhanced the infrastructure so that we can look to the future. How can we proactively detect and repair? The idea here is that we can issue a mailbox repair request, get back a task ID, and issue get mailbox repair request against that task ID to determine its status. In this case, I have 3 different corruption types being repaired, and it was completed. It tells me how long it took and that it's 100% complete. These are only available in the lifetime of a process, but we find this extremely useful for being able to determine the progress that's being made on a particular repair request. Some managed availability scenarios. We didn't make a lot of changes in SP1 here. For reference, I'll skip ahead here. I want to cover this one briefly in about a minute. Some store enhancements we've made going into the future. Like Nate said, we don't have a specific schedule of when we'll release these, either in customer updates or in future service packs. But these are the three main areas that we've spent some time on recently and are beginning to deploy into the service. Again, our general philosophy within our team is to ensure that we have full deployment of a core infrastructure like store changes in our data center before we turn them on by default in the on-premise. Pulsing index creation is one of the holy grails of store in terms of what is a worst operation. People ask, how big of a mailbox can we support? How many items can we support in a mailbox? Pulsing index creation is something that directly addresses that, because what happens is when you create an index over a mailbox, you have to generally lock that mailbox for the creation of that index. Take a static snapshot of what's in the mailbox, create an index over it, and then you can maintain that index. Pulsing mailbox or index creation allows for us to break that long operation up into a series of short operations. It allows other RPC operations to be interleaved with them so that the experience of an end user who may have requested a new view can go back to the previous view and still use their mailbox. Next time they go use that view, it'll be available. So it doesn't entirely change the experience of creating new views, but doesn't bring the mailbox to a denial of service, which is something historically has happened on large mailboxes in previous releases as well as 2013, until we're able to deploy this widely. Automated repair tasks I've talked about briefly. The idea is we want to proactively detect heavily used mailboxes, or even infrequently ones, on a periodic basis, and to use discretionary capacity available to us, as Perry referred to. It's free capacity. Let's use it efficiently to be able to prevent things like end user impacting corruption. Yep. And that's with that, we talked about the database support. What's Exchange Storage done over the years? We've reduced I/O. We did about 40 to 78%. I put a little star on there. It's between cached and online mode operation. We've optimized for large disks. We think we've got the I/O capacity for up to 8 terabytes. And mailboxes of 100 gigabytes in size, optimized for those large, slow disks. JBOD, use JBOD. You get the lowest cost COGS. Better isolation for higher reliability, and better monitoring and recovery for higher availability. And improved with every CU based on our service experience. I think that's been the biggest thing. If you don't use the service, you're still getting the benefits and the accrual of our experience there. Please complete your session evaluations, and thank you for coming today.